Now we're going to talk about evaluating limits algebraically. Okay, so here are some basic limits right here. The limit of b as x approaches c equals b. Now, why is that? This right here is your function, okay? And if f of x equals b, think about what that graph looks like, right? That is, so b is just a constant, so say b equals 2. That graph looks like this. So what is your limit as x approaches any c value? That limit is going to be b. Okay? Same thing with the next one, limit of x. So f of x equals x, that line looks like this. So the limit as x approaches c, that equals c, right? All you're doing is going to plug that in. And same thing with limit of x to the n as x approaches c is c to the n. Basically, you're just going to plug in that c value. Okay, so examples, limit as x approaches 0, 4. Again, that's just, this is your graph. So when x approaches 0, that y value is 4. The limit of x as x approaches negative 4, we're just going to plug negative 4 in. Okay, and that's again, f of x equals x. As you approach negative 4, the y value is also approaching negative 4. And then the limit of x squared as x approaches negative 2. So if you look at x squared, as x approaches negative 2, that is going to be approaching 4. Negative 2 squared is 4. Okay? Now, the next page, we are looking at evaluating limits by plugging in x values. The first way to plug in, or the first way to evaluate a limit is to plug it in. Okay, when we plug in negative 2 here, we get negative 2 squared minus 4 times negative 2 plus 1. So that's 4 plus 8 plus 1. That limit equals 13. Okay, example 2, when we put in negative 2, 2 times negative 2 minus 6, so it's negative 4 minus 6 is negative 10. And negative 2 minus 2 is negative 4. Negative 10 over 4 reduces to 5/2. So direct substitution is the first way to evaluate limits. Now, if you get an indeterminate form, you may have to factor, reduce, or rationalize the denominator first. All right, so looking at example 3, if we plug in negative 2, I'm going to do it over the side to leave me room. If we plug in negative 2, we have negative 2 squared minus 2 times negative 2 minus 8. So that is 4 plus 4 minus 8 is 0 on the top. And negative 2 squared is 4 minus 4 is 0 on the bottom. You get 0 over 0. That's indeterminate form. So what we're going to do is factor. You're still going to do the limit as x approaches negative 2, but we're going to factor. On the top, we have x minus 4, x plus 2, and on the bottom, x minus 2, x plus 2. X plus 2's cancel, so now you have x minus 4 over x minus 2. Now direct substitution, you get negative 6 over negative 4, which reduces to 3/2. Okay. The next one, when you plug in 1, 1 squared minus 2 times 1 plus 1 is 0. Right? 1 minus 2 plus 1, and then 1 cubed is 1 minus 1 is 0, indeterminate form. So we look to factor. We're still going to have the limit as x approaches 1. Factor on the top is x minus 1, x minus 1. Ooh, that's a difference of cubes on the bottom. So that's x minus 1 times x squared plus x plus 1. X minus 1's cancel. Now when we do direct substitution, 1 minus 1 is 0. 1 plus 1 plus 1 is 3. 0 over 3 is 0. It's okay to have a limit of 0. Okay? It's just when it's 0 over 0, that's indeterminate form. Okay? Example 5. This one right here, you cannot... Let's see, if I plug in 0, I get root 1 minus 1 is 0 over 0. So what we're going to have to do here is rationalize the denominator, or the numerator. In this case, it's the numerator. So to rationalize, remember, if it is, so let me start here, the limit as x approaches 0, root x plus 1 minus 1 over x. We're going to multiply by root x plus 1 plus 1, the conjugate. Remember that word? No, you learned it at some point. Okay, so you're going to multiply top and bottom by the same thing. So on the top, you get x plus 1 because root x plus 1 times root x plus 1 is x plus 1, plus root x plus 1 minus root x plus 1, they cancel, minus 1. So on the top now you just have x, and on the bottom, x times this whole thing, okay, I'm going to erase this and do this all in one step here, save room, plus 1 minus 1 cancel. So now I have x over x times this thing, x's are going to cancel. Now when you do the limit as x approaches 0, you get 1 over square root of 0 plus 1 is 1 plus 1 is 2, so you get 1/2. Okay, that's called rationalizing the numerator. You multiply by the conjugate. Example 6. If I plug in 0, I get 3a, all of that squared, which is 9a squared minus 9a squared, so that's 0 over 0. So, multiply that out. 3a plus h squared is going to be, so I'm going to put in my limit as h approaches 0. Let's see, 9a squared plus 6ah plus h squared. Oh, and then minus 9a squared all over h. Well, the 9a squared and the 9a squared cancel, right? 9a squared minus 9a squared cancels. Here you have 6ah plus h squared over h. I'm going to move this up here. Sorry. What I'm going to do is factor out an h on the top. So now I have 6a plus h all over h. Those h's cancel. So now I'm doing the limit as h approaches 0 of 6a plus h, and that equals 6a. Okay? So there you go. That is that. The next page is some problems for you to try. Okay? So what I'd like you to do is pause the video, try them, and then I will pause the video now, try them. When you open it back up, I'll have the answers up there. Alright, there are your answers to the U-tries. So go ahead, pause the screen now. You can see through my work. I did show the work on all of them, so you can check your answers. And there you go.